Is it possible to implement green flying? There is no doubt that aviation industry has a great impact on environment. Various non-governmental organizations, NGO, worldwide are searching for the best ways to solve the issue of rapidly growing carbon dioxide emissions as the number of air passengers exceed every forecast. And not just NGOs, as aircraft manufacturers are carefully designing new engines and other solutions to reduce carbon emissions. However, the movement towards eco-friendly aviation is barely scratching the surface of the issue despite the effort. So, what is happening in the industry towards green flying initiative and what can actually be done on limited resources? The International Air Transport Association, IATA, revealed that present trends in air transport suggest passenger numbers could double to 8.2 billion in 2037. The association warned, however, that growth prospects for air transport and the economic benefits driven by aviation could be curtailed if protectionist measures are implemented by governments. Over the next 2 decades, the forecast anticipates a 3.5% compound annual growth rate (CAGR), leading to a doubling in passenger numbers from today's levels. The 3.5% CAGR to 2037 assumes an unchanged policy framework over that period. Policy shifts, however, are likely over time. Should protectionism continue to expand in a reverse globalization scenario, aviation would continue to grow, but at a slower pace, and deliver fewer economic and social benefits. Under a liberalized environment, connectivity would generate significantly more jobs and GDP growth. The Asia-Pacific region will drive the biggest growth, with more than half the total number of new passengers over the next 20 years coming from these markets. Growth in this market is being driven by a combination of continued robust economic growth, improvements in household incomes and favorable population and demographic profiles. China will displace the United States as the world's largest aviation market, defined as traffic to, from and within the country, in the mid-2020s. The rebalancing of China's economy towards consumption will support strong passenger demand over the long term. India will take third place after the US, surpassing the UK around 2024. Indonesia is forecast to be a standout performer, climbing from the world's 10th largest aviation market in 2017 to the 4th largest by 2030. Thailand is expected to enter the top 10 markets in 2030, replacing Italy, which drops out of the ranking. While energy generation and agriculture currently dwarf aviation's 1.3% share of all human-caused greenhouse gases, emissions from air travel are accelerating many times faster. That puts the industry on track to become the single biggest emitter of carbon dioxide within 3 decades if the predicted cuts in other sectors materialize, data and projections from UN agencies show. Flight emissions are seen rising while other sectors cut back. The International Civil Aviation Organization recently moved to address the omission of airlines from the 2015 Paris Climate Accord by adopting self-policing guidelines that call for offsetting any carbon increases by planting trees or investing in cleaner technologies. Mandating direct cuts was deemed politically infeasible since it would have dented record demand for work and holiday travel, particularly in bustling Asian economies led by China and India. The problem with such a model, green campaigners and analysts such as Andrew Murphy at Transport and Environment say, is that it's already been tried and didn't work. At least 3 European carriers, Austrian Airlines AG, EasyJet plc and Virgin Atlantic Airways Limited, have paid to have forests planted in poor countries far from their home markets, only to see local authorities promptly cut them down. Airplane pollution, which has risen by about 2/3 since 2005, is forecast to jump as much as 7-fold by 2050 as incomes in developing economies advance, making flying more affordable for hundreds of millions, if not billions of people, according to the Montreal-based ICAO. The International Air Transport Association, or IATA, the industry's biggest trade group, expects the number of airline passengers to double by 2037 to more than 8 billion a year. Number of aircraft flying is seen doubling over the next 20 years. The surge in demand is swelling the global fleet of commercial passenger craft, which Boeing company sees doubling to 40,000 in the same period. The pool of private jets is increasing at a similar pace, with Jetcraft, a market intelligence firm, predicting a 50% gain within a decade to 30,000 from 20,000. Add cargo and military craft into the mix, and total air traffic will probably grow 4.4% a year on average over the next 2 decades, requiring the overall addition of 37,000 new planes, with a combined value of $5.8 trillion, according to Airbus SE, Boeing's main competitor. All of these forecasts are terrifying climate scientists and activists who say increasing concentrations of greenhouse gases are leading to rising temperatures, more extreme weather, and higher death tolls from natural disasters. Probably the biggest issue for green flying is the actual flying. People are constantly traveling by plane, and it would be extremely difficult to persuade them that any other mean of transportation would be much more environmentally friendly. Mostly because at this age time is money, and flying saves time. Besides that, travels by aircraft became a lot cheaper, especially with low-cost airlines, when tickets for vacation can cost as low as €10 per person. However, what is the real cost of so many flights? According to the International Air Transport Association, IATA, at the moment around 4 billion passenger seats are sold in civilian airliners every year, meaning that nearly half of our population flies every year. It is predicted that by 2036 the number will double. Every year the number of air passengers grows by 5%. The irony, everyone worldwide is talking about carbon emissions and searches for the ways to minimize it, but flies more than any year before. Of course, one might say that aviation is just a very small player in carbon emission environment, and it would not be wrong. Only 2% of global carbon emissions belong to aviation industry. However, these 2% convert to 859 million tons, which still is a great issue in the worldwide context. Some of the solutions to this ongoing and still rising issue are obvious. We should stop flying so frequently. But is it really a solution? Aircraft manufacturers are working daily to create engines that would use less aviation fuel and would be more efficient. However, knowing the aircraft fleet worldwide is not changing as soon as the new aircraft engines being released, these changes would not be implemented soon enough. The other solution is to adapt current aircraft for biofuel. Some airlines are already flying with biofuel. In the past decade, aircraft are allowed to run with synthetic kerosene. ASTM International, the organization that sets standards on jet fuel, allowed having up to 50% of biofuel in jet tanks, and by this day we already had around 143,000 such flights. Yet again, this is an extremely small amount of scheduled flights, as only in 2018 there were 39 million of them. There is also another issue being raised: if biofuel will be used, will there be an issue for food growing and using it for fuel, rather than feeding people worldwide? The most interesting suggestion is to use electricity instead of fuel. Major industry players, research organizations and entrepreneurs are working on several possible paths to make commercial electric flying a reality within a few years. Here are some of the most promising initiatives in the field. A product of Airbus's Silicon Valley arm, Vahana is an unmanned electrical aircraft designed to move a passenger or small cargo within the confines of a city. Its appearance is straight out of a science fiction film. The passenger module nestles between two parallel wings, one above and one below, each holding 4 engines. Its vertical takeoff and landing capabilities make it possible to fly from building to building, which may turn into an alternative to land-based urban transportation. Vahana also incorporates technology that allows it to avoid obstacles and navigate the complexities of the urban environment.
The fast emerging market for electrically powered vertical takeoff and landing aircraft now seems to have all the sense of urgency of a gold rush. Dozens of startup ventures are eagerly striving to get their cutting-edge designs certified to enter service. The field also includes established aerospace industry players, including Airbus, which is advocating a somewhat more patient approach in view of the many challenges the so-called eVTOL sector faces to fulfill its potential. Airbus's Urban Air Mobility division is working on 2 designs that it hopes will prepare the way for its first eVTOL model. It does not intend either the single-seat Vahana or the 4-seat City Airbus aircraft to ever enter commercial service. But it believes that the lessons it is learning about factors such as electrical power, autonomous flight controls, and the aerodynamics of vertical takeoff and landing will be vital in ensuring the success of the new design it quietly started working on in early 2019.
The biggest problem of these machines is that the regulatory framework doesn't exist yet. This includes a set of new technologies that are also new for regulators, which means we as industry, we really need to closely cooperate with them so that we're able to put safe products certified out there.
For Airbus, eVTOL aircraft are a powerful response to public demand for air transport to be more environmentally friendly. It views both the Vahana and the City Airbus programs as useful platforms for lower carbon green technology that could eventually find its way onto larger aircraft. At the same time, the European group insists that to have a lasting future, eVTOL aircraft will have to win public acceptance by avoiding unacceptable noise and visual pollution, and also by achieving full integration with other modes of transportation and city infrastructure. But above all, Airbus insists that safety must be the #1 criteria for determining whether and how the eVTOL dream can be achieved and sustained. And this is why it is advocating a somewhat more cautious approach than some would-be pioneers who are pushing hard for early adoption.
We will also require integration with air traffic control. And more importantly, in the future, when autonomy is there, we will also need to have systems that allow autonomous vehicles to be sharing the airspace with more traditional piloted vehicles, which represents as well an additional challenge. So we believe that this is going to happen. I think we need to stop dreaming, we need to start making, and we believe that we need to be also socially responsible, because safety is going to be priority #1. This is an all-new story. Urban air mobility was already in place in New York, in the 60s, 70s, where people were flown with helicopters to the center of Manhattan from the airports, and that market didn't flourish because of safety issues. We don't want to repeat history again. We want to take every step and don't take shortcuts, because we believe that if we endanger safety, this will close that market and it will not open up again.
Another futuristic concept that Airbus is working on is City Airbus. After successful tests on the ground, Airbus Helicopter will soon be carrying out in-flight tests on its City Airbus unmanned airborne taxi with vertical takeoff and landing. The 8-blade powered craft can transport 4 people for 15 minutes and is one of around 120 projects involving similar vehicles that specialists around the world are currently working on. Just like Vahana, it's self-piloted and will be able to take off and land vertically, making it ideally suited for urban use. The difference is that City Airbus will be able to carry up to 4 passengers. In addition to zero emissions and low noise levels, Airbus is confident their operating costs will make them competitive with traditional taxis. In parallel to these projects, Airbus continues to work towards its longer-term aim of developing a fully electric airliner. The next major goal will be to develop an aircraft that crosses the megawatt threshold. Airbus has plans underway for a 2-megawatt aircraft. It's still a long way off what would be needed to power an alternative to present-day airliners, but already more than 60 times more powerful than the E-Fan's 30 kilowatts. Airbus reveals also futuristic blended wing concept. The European aircraft maker has released a new curved design that promises to cut fuel consumption up to 20%.
A couple of times a year, the aviation industry is lucky to have an air show with major players in the industry visiting, announcing orders and future aircraft potentially as well. Currently, there is the 2020 Singapore Air Show, which is ongoing, with the first day now having come to a close already. Albeit with problems surrounding with the coronavirus, it certainly hasn't lived up yet to potentially what some would have expected of an air show. What is a given almost most definitely is new concept aircraft being revealed during air shows. It's something we've become rather accustomed to in the past. However, this time, we've had Airbus reveal their Maverick. Now, that's the model aircraft for validation and experimentation of robust innovation controls and breathe. The Maverick for short, which I will be referring to it as in the future, is a blended wing airliner. The way it is designed is for means to cut CO2 emissions by some 20%. However, this testing has indeed been kept well under wraps, partially down to its actual scale. Back in June of 2019, a test aircraft did indeed fly in France. While the test aircraft is closer to a model plane in size, it allows Airbus to improve their knowledge on the subject and more closely refine potential problems, while also generally, as mentioned, working on efficiency and bettering all features of the aircraft. The fly-by-wire technology, which is required to control an aircraft like the Maverick, still needs testing within Airbus, and these flights, albeit on a smaller scale model, can be incredibly helpful to them. The size of the model isn't big. In fact, it's only 2 meters long, or 6.6 feet, while being 3.2 meters wide. The surface area is 2.25 square metres or 24 square foot. The EVP of Engineering Airbus said Airbus is leveraging emerging technologies to pioneer the future of flight. By testing disruptive aircraft configurations, Airbus is able to evaluate the potential as viable future products, adding, "Although there is no specific timeline for entry into service, this technological demonstrator could be instrumental in bringing about change in commercial aircraft architectures for an environmentally sustainable future for the aviation industry." While this is very exciting to see, it's not exactly clear what the eventual size of a flying wingtip aircraft will be with Airbus. In addition, what aircraft it would replace and what its seat capacity would be. We only really got a rough idea with some comments, but as mentioned, you really can take these with a grain of salt so early on in the program's testing. Someone said for the equivalent seat count of a tube and wing aircraft, the footprint of such aircraft is much smaller, indicating maybe potentially at it being for smaller planes. We're going to have to wait and see on that front. It's just way too early to tell. It's no guarantee that in 50 years a plane will look like this. However, the important studying, test flights and knowledge building will all go an incredibly long way in building more efficient jets for the future. It's been definitely a slow start to the Singapore Air Show, hence the whole 4 video a day average when an air show occurs being thrown out the window. I suspect with a lot of exhibitors pulling out of the show, it'll remain rather quiet for the next few days, with here's hoping one major story a day to cover for you all. What are your thoughts on this concept though? Do you believe it will ever really get off the ground? When I say it like that, I mean with passengers on board operating commercially. Drop your thoughts down in the comment section below.
When it took the wraps off its electric vertical takeoff and landing (EVTOL) air taxi concept in January 2019, Bell revealed a different approach to urban air mobility.
Bell unveiled its Nexus eVTOL air taxi concept earlier this year at CES, but we had the chance to catch up with Bell's VP of Innovation, Scott Drennan, at Heli Expo 2019, where he told us all there is to know about the project at this point. This is a long-form video for those of you who want to drill deep into the future of eVTOL and air taxis from Bell's perspective. Let us know what you think in the comments.
So Nexus is a powered lift aircraft with 6 fully tilting ducts. So it flies in its current configuration as a helicopter, and then in its converted configuration like an airplane. We chose this redundant configuration to use redundancy to get to the reliability numbers that we need ultimately for certification. There's been this interesting conversation in this market space about how redundancy automatically, so to speak, equals reliability. But as we all know, being in the industry, that's not necessarily the case. Sometimes you can have reliable systems that are non-redundant, like we do in traditional helicopters, the mast, the blades, etc. And then systems on those helicopters that are redundant, like flight control computers or actuators, but both have the same purpose, and that is to create reliability. So this is a vehicle that has more redundancy than our traditional vehicle, and so therefore relies on it to get to the reliability numbers rather than reliability of individual components, although that will have to be there as well, but not at the same level that we normally certify to. You'll see the cabin is in a 4+1 configuration right now, and translated into payload, 800 to 1,000 pounds of payload. We say 4+1 because we're leaving room for the pilot to be there in the beginning of the certified operation models, both in case there's still regulatory questions, but also because we believe our customers might demand that from the initial flights. And then once we get the data there and the societal or community acceptance, we'll take that +1 and turn it into another paying customer inside the vehicle. The vehicle's gross weight, we're targeting somewhere in the 6,000 to 7,000 pound range, all with the idea of staying below a Part 29 type certification, and using certification knowledge and experience that we initially developed on the 609 with the certification basis we wrote for that vehicle. But then, of course, trying to take advantage of the new performance-based specifications in Part 23, which we believe are quite applicable to an aircraft like this, and in some of our initial studies to date have turned out to be really good. So the time frame that we're offering is about the time frame when we believe a certified operational vehicle can be out serving the public, and that we believe is in the mid-2020s, so the middle of this decade. In terms of our first flight, we're not disclosing when, but you can, kind of string together between now and 2025. We don't have a lot of time, so it's it's coming up.
What lessons have you learned from the V-22 and the tilt rotor that transfer to this?
Yeah, thank you. It also includes not only the powered lift vehicles of the V-22 and the V-280, but it even goes back earlier in our history to the XV-22, where we flew a tilting ducted vehicle, and we learned a lot there about ducts and disc loading. Then for both that vehicle and the V-22 and V-280, of course, we know everything there is to know today about the conversion corridor, and we'll be applying that learning here, and then the difference dynamically between flying like a helicopter and flying like an airplane, and everything that happens during that conversion. So that's been really helpful learning.
Ducted aircraft just haven't made it.
Right.
So what's the difference now?
So what's interesting about past technology that people have incubated is that back then, there were other things that didn't exist, like fly-by-wire, the actuators of today, the EMAs. And then we also knew we needed to help get the most efficient vertical takeoff and landing machine laid in because of the desire for our customers to have more electric vehicles. So that more electric vehicles translates to us as less power available, and therefore we have to make a more efficient aircraft, and the ducts really help us with the VTOL portion of the mission because they augment the thrust across an open rotor. Both the V-22 and the V-280 are fly-by-wired powered lift vehicles in the form of a tilt rotor. This is a powered lift vehicle in the form of a tilting fan vehicle, but everything we learned about fly-by-wire and control applies to this as well. With a few more challenges because it's a little different than a tilt rotor. But
So right now there's lots of major cities that are restricting helicopters flying over the cities and certain heights and everything else. So how are you addressing it?
So we're addressing that primarily with noise. So the vehicle that we have here has much lower tip speeds than we're all accustomed to on traditional helicopters. Tip speed is the primary driver of noise, both on the tail rotors and the main hubs of a traditional helicopter. And then the second piece that we have are the ducts. The ducts are really doing a great job shielding the noise, changing the tonality of the noise, and also giving us a lot of directionality. The noise on the ducts is distinctly different on all the azimuths. And that, if we couple that with the right operational models, it's going to really blend in nicely to urban ambient noise.
What about flight in icing conditions?
So we're studying the possibility of all weather conditions. It's critical in this market because the expectations are to fly, up to 2,000 hours per year. That's relatively rare in the helicopter fleet today, and so in order to really do that and let the business case close, we're going to have to address all weather conditions. We're not doing that with our demonstrator vehicle, but we're studying it. Of course, it has to be lighter, more cost effective, and less of an energy hog than traditional de-icing systems are on traditional vehicles.
How do you manage the failure of the engine?
Yeah, the Nexus currently has a single engine series hybrid with a battery pack on board. That battery pack serves two functions. It serves to help with transients and power, and it serves to land our customers under full power and full control should we experience an OEI event. It's roughly 4 to 5 minutes, very similar to the time it takes a 407 to auto-rotate and get to the ground.
Hey, what kind of engine is it?
It's a Safran. Safran does the gas turbine, the power distribution system, and the electric motors. And then a company called EPS, Electric Power Systems, does our energy management and batteries.
And
And if you lose one fan?
Yeah, we would plan to be fine there. Yep. And you know, remember with distributed solutions, you don't get just to turn off one. You usually have to turn off the other one on the other side to get the aircraft balanced, and that applies to any of these kind of vehicles.
So what system or component are you most concerned about?
It's really the battery and motors, but not from a technology standpoint. Our partners know how to deal with that technology. It's from the weight standpoint, because as soon as they're continuing to evolve, but as batteries and motors get lighter and lighter, more energy dense or power dense, however you want to classify it, that is going to be just a great evolution in these vehicles. Better missions, more missions, longer missions. And I think that's the biggest challenge we have. Power electronics are heavy as well, but
how much would be turnaround time to charge batteries on this stuff?
So we haven't done any integrated system tests with the partners there, but there are ChargePoint and Uber are talking about 5 to 7 minute charge times. That is in a system whereby you're not bringing the battery all the way down to low states of charge. You're doing, shorter bursts of, 25 miles at a time, 80% state of charge, back to the charge, and out again. And that'll come with some cooling of the battery system. That'll be a combination of what's on board and off board in the infrastructure.
Any particular cities that you think this would be deployed in first?
Yeah, I mean, I think there are cities that we've heard about from Uber, Dubai, Dallas, Los Angeles. There's still a lot to be seen about what can we do in the certification environment in the U.S. and how hard those cities want to drive with us versus what we can do in other municipalities that have a different certification arrangement, either in Europe or in places that control their own airspace. They could help with the time period.
How much has Bell put toward this program?
So I can't quote numbers of my IR&D spend, but my team has grown over the last 3 years from my 25 original folks that I knew from my history at Bell, and we're at 130 right now. I'm probably going to grow to about 175 people by the end of this year, just on my engineering innovation design team. To me, this is more familiar from an interior standpoint than anything that you would experience in a traditional helicopter. It has more of an automobile feel. There's connectivity for devices. There's a very compartmentalized, sleek look to that. And we also have a really simple cockpit display here. This is our Garmin display, really aimed at, think about simplified vehicle operations that combine just the information you need plus very simplified control effectors. We're still experimenting with the format of the control effectors, but we know we won't be doing pedals, collective, and cycling. And we have a wonderful program called the Future Flight Controls Program that we built 3 simulators, and we put people through the simulators, and there's a data algorithm behind it that Texas A&M does for us to determine the relationship between that person's training and familiarity with flight and that person's success on the course inside the simulator. And it tells us what controls are most intuitive to non-professional and professional users. You'll notice a flat floor, so these seats and these center consoles can come out and present a flat floor with our tie-down rails in it. So if you wanted to put a pallet in here to do a logistics mission or an EMS mission or even a police mission, a parapublic mission, we believe the vehicle will be ready for that given its modular design. Our demonstrator will be fully autonomous. It will not have a pilot on board, and the combination of Garmin and Thales will set the foundation for the vehicle management system, the vehicle management computer, which is kind of the central brain that tells you, where and what we're trying to do, and then the flight control computer that tells you how we're going to do it through our control laws and the interaction between that computer and the control surfaces outside. Now, we also have system integration labs we're setting up, and those are running so that we understand the electronics, the avionics, and the flight control computers and how they interact with each other. And then we have an autonomy SIL as well at Bell, where we're studying the autonomous capabilities of the vehicle and the interface between how much is on the vehicle and how much is on the ground. You know, there's this whole debate around, can we create a deterministic system that's still autonomous or automated versus a non-deterministic system? The non-deterministic systems are hard to certify. And if you think of the ultimate autonomy goals, that it might be true that they're non-deterministic because they have behavioral type capabilities. But you know, initially we need to find a deterministic system that combines the onboard autonomy, the infrastructure external to the aircraft that helps you with flight and navigation and emergency response to contingencies, and then we can have a deterministic system like we do now. So I'm worried about that. Sensors, you know, sensors need to have, you know, better range. The computers that are going to, look at all that data have to have better latency and computational power. Although, you know, that's pretty easy to get. But the sensors need to be smartly integrated, understanding their limits, and understanding how they interact with any given aircraft configuration.
Ground vehicle, sometimes the vehicle has to make the choice to save the passenger or to save the outside person. Do you have the same kind of
No, there's
issue?
much. I call those the moral conundrums of autonomy on the ground. Those don't exist in the air. It's binary. You do not connect. You do not hit anything or do hit something. So that's the first nice part about it. The other nice part is we'll be interfacing initially with professionally trained pilots, not amateur drivers like us. And then the third piece is you'll ask, what about during takeoff and getting to the ground? That's where we have to have predefined known offshoots so that if something were to happen and the autonomous system needed to land, it would already know based on its position in the route where it had to go, and then the sensor pack would take over to make doubly sure that area is clear and then land. So we're already flying, the APT vehicle back here, it already flies fully autonomously for us. So all of our learning there is helping us develop the system for this. But you heard me say again, it's a combination of the vehicle and the infrastructure in the airspace and on the ground. That's the smartest way to get that done in a safe manner, and safety is number one for us. It's a really exciting time. Our industry is changing like it's never changed, since maybe the jet age came in, and that's just a wonderful time to be a part of this. And I'm not saying there's not challenges, but it's becoming a when question, not an if question anymore.
U.S. multinational Boeing has invested together with Silicon Valley's JetBlue Technology Ventures in Seattle-based startup Zunum Aero. Zunum's hybrid electric aircraft promises something akin to door-to-door air travel, flying quietly and economically to thousands of underused local airfields and bypassing more inefficient and often congested larger airports. The initial concept will be able to carry 12 passengers up to 700 miles, but it's been designed with scalability in mind. The idea is to develop a family of aircraft of increasingly larger size and longer range. Although it starts as a hybrid, its design allows for a smooth transition to full electrical propulsion when new battery technology becomes available. Batteries are included. Zunum Aero's regional hybrid electric plane stores lithium-ion batteries in the wings for supplemental power, particularly on takeoff. Cruising power is generated by a gas turbine linked to a generator in the back. A common denominator in these efforts is better batteries, above all lithium-ion batteries, which continue to pack ever more energy into lighter cells. Such energy density is especially critical for aviation. Since 2010, battery pack costs have fallen from US $1,000 per kilowatt-hour to less than $250 kilowatt-hour today, with a concomitant increase in energy density. Other critical technologies, such as supercapacitors and power converters, have likewise improved by leaps and bounds.
What kind of future are we heading towards? Is it possible that short flights with an electric aircraft will become commonplace? As highlighted in my Uber Elevate video, battery technology is finally starting to improve, and we're just touching the state where a fully electric aircraft has just become feasible for some applications, mainly flight training and short distance travel. The aircraft in question is the Pipistrel Alpha Electro. Founded in 1989, Pipistrel is a company based in Slovenia that specializes in manufacturing light aircraft. Categorized as a light sport aircraft and only weighing 350 kilograms including batteries, the Alpha Electro is the first fully electric aircraft certified for flight training. The cost of a new aircraft is about $100,000. On board, there's a 20 kilowatt hour battery, which translates to a flight time of over an hour plus reserves. This makes flight training the perfect application. If needed, the batteries can be swapped out in 5 minutes. The electric motor that powers the aircraft is 60 kilowatts and only weighs 11 kilograms. Because the plane is so light, it can literally be pushed and dragged around by one person with ease. I found it a sight that still takes some getting used to. Unlike a regular petrol-light aircraft which uses 50-year-old engine technology with hundreds of moving parts, the Alpha Electro has only one moving part, and hence the aircraft is safer and much easier to fly. There's only an on switch and a throttle lever to operate the engine. Normally, engine operation would be much more complicated, with tasks such as mixing fuel on the fly. The company that got delivery of this aircraft is Electro Aero in Perth, Western Australia. Electro Aero hopes to carry out pilot flight training at a fraction of the cost of regular aircraft because there's no fuel costs and far less maintenance costs than the status quo. Right now, it costs about $3 per hour to run the aircraft, and that's about a tenth of the cost of a fuel engine. The result cuts the rate of flight training by about $90 per hour in comparison to a plane like a Cessna 172. During the first 40 hours of lessons, an aspiring pilot could save over $1,000. So now it was time for the first of these aircrafts to arrive in the Southern Hemisphere. The Alpha Electro came in a shipping container from Slovenia where it had been manufactured. An aircraft coming in plastic wrapped pieces was certainly something unusual, and it distinctly reminded me of an unboxing, which I posted on my Twitter and Facebook as such. I was there when the plane was being assembled in an aircraft hangar in Jandakot, south of Perth. Remarkably, the process only took a couple of hours and was pretty painless. After a quick test flight, it was ready to go. Electro Aero are the first company in the world to have this aircraft certified, even before anyone in the United States and Canada. And that makes this aircraft the very first certified electric plane in the world. I sat down with Electro Aero's CEO, Josh Portlock, and had a chat with him about the aircraft.
So the Alpha Electro being the first certified electric aircraft in the world, and we were the first to get that certified at Electro Aero, is a great opportunity to commercialise electric aviation in the training sector, where the cost savings are very beneficial to pilots getting their licenses. But longer term, we want to certify 4, 5 and 6 seat aircraft, allowing air taxis to utilise electric propulsion. In air taxis at the moment, they're using petrol engine aircraft that are designed for longer flights, but are only being used for 10 to 15 minute flights. That means the engines are being started and stopped much more often than they're normally designed for. Therefore, there's much more wear and tear on the engine and a lot higher maintenance expense and cycles. In electric, it doesn't matter how many times you start and stop the motor. It's not having to go through a major thermal cycle every time. It doesn't have hundreds of moving parts, just the one rotating part, and direct drive, no gearbox. So the short hop flights of sub 1 hour are perfect for electric. The batteries can already do it. The maintenance is not affected by the thermal cycling like an engine. So this is the front battery compartment where it stores a 10 kilowatt hour battery. So there's a battery in the front and in the rear. So the two batteries combined get just over an hour of flight time, and it gives us redundancy. So if one of the batteries fails, the other battery can keep flying the aircraft and give you typically half an hour sort of reserve to bring the aircraft down. Normally you've got your engine taking up this much space, but instead the electric motor only takes up this much space. It's quite compact. It's a pancake sort of size motor. The charge port is under here, very similar to the Tesla. The Alpha Electro is fitted with a ballistic parachute. That means that in the event of a control system failure or a catastrophic airframe failure that you couldn't glide down, because that's your first choice of safely bringing the aircraft down, you can pull the big red handle and it will launch a rocket out of the roof of the airframe and pull a parachute out. And it's an entire airframe parachute. So the straps that hold the airframe are under these covers, and it'll actually be floating down to the ground on that parachute and landing safely so that the occupants can safely get out the aircraft. The Electro Alpha has an EPSI, which is an electric power instrument system, It has a Garmin GPS that's a capacitive touchscreen, so you've got your ability to pinch zoom just like a mobile phone. So it's like a modern day glass cockpit on a nice portable device, so it can unclip from here and you can take it home to program in waypoints or flight plans.
When the plane was set up and the hard work was out of the way, it was time to celebrate. There was a few speeches, and a Tesla came in for a symbiotic photo opportunity at a glimpse at a possible electric future. Over the next couple of days, local news teams came to check out the electric aircraft and take a ride in it. There was keen interest and genuine curiosity.
Now to the aviation revolution that's taken off in Perth. The world's first fully electric aircraft has hit the skies, and its owners believe it's just a taste of things to come.
This plane is the first of its kind in Australia.
A Perth company has launched a revolutionary electric plane that could change the way we fly.
It could be the future of flight in WA, a revolutionary plane that runs on electricity with the power to slash operating costs and fares.
Probably the quietest takeoff you've ever heard. An electric plane, the first of its kind in the Southern Hemisphere.
So how is it like to fly inside? If you've taken a flight inside any light aircraft, it's basically like that, but the views are better because the windows are unusually big. That aside, the main thing you'll notice is the noise, or lack thereof. It's a lot quieter than the average petrol plane. Most of the noise is from the propeller itself and the air rushing past the cockpit as you're flying. I took the controls for about 30 seconds and was surprised at how sensitive it was. Just a light press from your index finger could have you banking at a healthy angle. Now that some test flying had been done by some of Electro Aero's pilots, it was time for a challenge. The team was going to attempt the very first cross-country flight in Australia with an electric aircraft. The team composed of Rob, the pilot, Richard, the finance director, but also a pilot himself, and me, who would be documenting the day's events. The plan was for Rob to fly from Jandakot Airport to a rural airport called Dale River, which was about 70 kilometres away. At Dale River, we would then use a portable generator to recharge the plane. After this, Rob would make the return journey. So, when the day came, we all met at Jandakot Hangar at 7 AM. We performed some checks on the charger and loaded it onto a truck and checked the weather to see if it was suitable for flying. From there, Rob took off while Richard and I drove to Dale River Airport. When I arrived at Dale River Airport, I thought it looked more like a patch of abandoned farmland near a highway than an airport. Regardless, Richard and I would wait for Rob's arrival. For safety, the team devised a decision point. The decision point comes into play when the battery is at 65%. If Rob hasn't flown half the distance at this point, then it would be best for him to turn back and land. The main concept is you never want to break through that 30% reserve battery. There would be nowhere to land in between Jandakot and Dale River, so this was important. On the ground, we could track Rob's flying in real time with an iPhone app, which I thought was pretty cool. After a while, we had a visual, and he touched down shortly afterwards. I asked Rob about the flight, and he said that he was worried because the plane was climbing too fast due to an unusually strong headwind. This was a concern as the battery tended to drop quickly under these conditions because of the extra power used. So at this stage, the plan was to recharge the plane using the portable generator. Unfortunately, for an unknown reason, the generator couldn't handle charging at the full current and shut down immediately when it was tried. It was funny because it was supposed to take this rating. When at half power, the generator would work for a while before conking out. It needed to cool down for about half an hour before we could try again. After a few hours of frustration in the hot sun, we finally got enough energy into the batteries to make a safe flight back to Jandakot, and this completed the first cross-country return flight in Australia with an electric aircraft. And for the truth being told, this situation vividly highlights the limitations of electric aircraft at the present moment. For cross-country flights to be more practical in the future, you wouldn't want to depend on an old generator, and you would need a supercharger 3-phase power system readily available. Until this infrastructure is in place and battery energy density improves, for now, it's only really flight training that is the optimum use case for electric planes. I see longer flight applications being about 2 to 5 years away. So all in all, it's an interesting state that we're at right now. We're definitely at the beginning of something new. Anyways, that's going to do it for this video, and I do have a special treat for you if any of you happen to live in Perth, or do want to see the Alpha Electro in person and fly it. I've teamed up with Electro Aero for this video. If you use the discount code COLDFUSION, you can get $50 off your first flight, and I'll leave the appropriate links below. As a side point, Electro Aero are actually doing some other pretty cool things. One of them is a patented design for electric propulsion systems, which has won the company some big contracts.
NASA marked 2 major milestones in the effort to develop the agency's first crewed X-plane in 2 decades, the all-electric X-57 Maxwell, which will fly to demonstrate the benefits of using distributed electric propulsion.
At this point, throttle is idle, right motor area clear.
Progress is being made in the vehicle's initial transformation into an electric aircraft, a phase of the project known as Mod 2. Engineers for the first time installed and tested both electric cruise motors with their propellers at the same time.
Both motors stable at 400.
The spin test verified that the motors and propellers operated as expected under significant amounts of power. These tests, performed at Scaled Composites in Mojave, California, precede delivery of the Mod 2 vehicle itself to NASA, where it will undergo verification, taxi tests, and ultimately flight tests.
Back it in there, lift it up, he can drive out like the original plan, set it right back down like the original plan.
While the Mod 2 vehicle continues to take shape, NASA's team lays the groundwork for the project's next phase, Mod 3. The Mod 3 wing was delivered by Empirical Systems Aerospace to NASA's Armstrong Flight Research Center, where it is undergoing weight and balance measurement, ground vibration testing, and wing loading tests to verify the wing specifications.
This wing won't fly for a couple years. We're integrating our electric system into the wing, and then it will fly on our X-57 aircraft in what we call the Mod 3 configuration. At the same time, we've got our Mod 2 integration happening, where we've got the original low aspect ratio wing being integrated with our electric motors and battery system, and that's happening just down the street here and will be delivered to NASA in the next few months.
It is really hard to say what could be the universal truth for this rising issue. The development of new technologies will eventually serve to the purpose, but at this time, it is best to adapt the older fleet to timely standards. The best way to do so is by upgrading the aircraft with spare parts that would help to minimize the consumption of jet fuel even in theoretical level. New solutions as composite materials or aluminium lithium, advanced aerodynamic solutions like winglets or morphing wings. The reason behind this is that the fleet are not changing fast enough to be up to date with environmental standards, and maybe even the smallest adaptations of the aircraft or its engines, while working hand in hand with manufacturers and standardization organizations, would benefit to the cause.